Okay, last one. Well, not last one. For now, for the current time that I am at living, this is the last one that I'm caught up with where we are during class. So we have kinetic energy and friction, which fall under energy and motion. So all of this beautiful, well explained material, almost all of it, we were talking about heat energy. So here, heat released or heat put into a system, heat energy in joules, which is the transferal of temperature. And temperature was the kinetic movement of particles, right? So we've covered heat energy, and now we're going to cover another big energy form, which is kinetic energy. And luckily, it's way easier and more compact than whatever this amalgamation of death and horror is. So, kinetic energy and friction is on the table for today, and it is quite a simple thing. Certainly, if you compare it to our formula of like Q is equal to M times C times delta T, it ain't that hard for this one at all. Okay, so to understand kinetic energy, we need to find, well, you need to know the two factors that impact the amount of kinetic energy of an object. So, for example, this ball right here, this beautifully drawn football, it's sitting still, so it has no kinetic energy. Womp, wompity womp womp. Okay? It needs two things. Well, yeah, it has two things in order to have kinetic energy. And I'm going to show you those. Okay? So once something is moving and it has a mass, we have kinetic energy. So kinetic energy, as a reminder, is the energy of movement. So if this ball is shot through the air, then it has kinetic energy. Once it lands and completely stops again, it has no kinetic energy anymore. Anything that moves has kinetic energy. So, question one. Either we have this rock, and we'll call him Mr. Big, and he looks a little bit like this. And this puppy right here weighs a modest 1,000 kilograms. And then we have this other rock called Mr. Small, and it only weighs 10 grams. Little baby rock. Question number one. If you had to choose which one of these would land on your head, which one would you choose? Probably Mr. Small, because then you're not crushed to bits. Yeah? So if Mr. Small is moving, or if Mr. Big is moving towards your head, I think you would rather have Mr. Small moving towards your head, because this guy has a higher mass. And mass is one thing that affects the kinetic energy of an object. So number one that affects kinetic energy is mass. If something has more mass and it's moving, it has more kinetic energy than if Mr. Small is moving at that same speed. So let's say they're both, then this is of course a smaller amount. Let's say Mr. Big and Mr. Small are both moving at 10 meters per second. Which one would you rather have thrown against your head? Probably Mr. Small, because he has less weight, and so his kinetic energy is lower. So the first factor that affects kinetic energy is Mr. Mass. The second one is as follows. Let's say we have two beautifully... No, okay, this is too poor, even for my standards. We have one club, which weighs... it weighs 10 kilograms, sure. Or a club that also weighs 10 kilograms, but there's a difference here. This club is moving at 100 meters per second towards your head. This one is moving at a mere 1 meter per second towards your head. Which one is going to hurt more? The 100 meters per second one. Yeah? If I hit someone with 100 meters per second with a baseball bat, that's going to send them to the hospital. If I do it with 1 meter per second, maybe they have a little bruise on their head. So the faster an object moves, the higher the kinetic energy. So the second thing that impacts kinetic energy is speed. So a heavy and a fast object equate to having a very high kinetic energy. Let's say you are not heavy but light and you are moving slow. What is the kinetic energy going to be? It is going to be low. A low kinetic energy. Okay? So these are the two factors that affect the amount of kinetic energy. The higher your mass, the higher your kinetic energy. The higher the speed, v is speed, velocity, the higher the kinetic energy. Okay? So that is the two factors that affect it. And how can we put this in a formula? So if we need to calculate kinetic energy, what two factors do we expect to see in our formula? Probably mass and probably velocity. And because you are so incredibly smart, that is exactly correct. And the formula exactly is half times the mass times v squared. So let's just give a quick example. Let's say, and just to make sure, mass is in kilograms, speed is in meters per second. That is the units of these. And kinetic energy, as always, it's a form of energy, so this will be in joules. That's our units. Let's do a calculation. Let's say there is a 100-gram croissant moving at let's do 10 meters per second. That's it. There's a 100 croissant moving at 10 meters per second. How can I now calculate my kinetic energy? I put everything in a row and let's find out what we have. Do I have my kinetic energy? No. Do I have my mass? Yes, it's 100 grams. What is 100 grams? In kilos, it's 0.1 kilograms. We divide it by 1,000. What is my speed? It is 10 meters per second. Yuppie. Now I can plug all these into my formula. Kinetic energy is half the mass, half times 0.1, times v, 10 squared. Yep. So this was my mass. I got that from here. And this was my speed. And then we put those into our formula. So what is a half times 0.1? That is 0.05 times 10 squared is 100. So I hope that my math is accurate here, that we would have 5 joules of kinetic energy. Please tell me that I'm right about this. Our EK is 5 joules. Yeah, that is an example calculation. Make sure that you convert your grams into kilograms. That's usually a step that is overlooked. Okay? So make sure that those units align. So this formula is quite simple, right? We just have half m times v squared. Another interesting thing that you should see in this formula is that we do half times our mass and we square our speed, which means that mass has less impact on our kinetic energy than speed does. Why? Because our speed, our 10 meters per second, is being squared, so being turned into 100. So that is increasing our kinetic energy a lot. Whilst our 100 grams is halved, so turned into just 0.05, and doesn't contribute that much to the kinetic energy. So the mass contributes less to kinetic energy than V does. And how can you see that in the formula? It's because V is squared. So whatever your speed is, you square it. So if I have a speed of 100, the kinetic energy formula would then be that it's squared. So that has a very large impact on what my final answer is going to be. Whilst if I have something of 100 kilos, I'm timesing that by half, turning it into just 50 in my formula. Whilst 100 squared, 100 times 100 is a big 10,000. Yeah. So the impact of speed is way higher for kinetic energy than mass is, because V is squared and mass is halved. That's a nice thing to know. That's just an extra little detail to know, which can help you in some questions to think a little bit out of the box. the main thing that you need to know is that this is the formula and this is how you calculate with it. So I'll just give you one more to do at home. Calculate kinetic energy for something with 50 grams moving at 15 meters per second. Good luck with that. Yep, so it's half times mass times v squared. Okay, another thing that you might be asked to do is that, for example, I can tell you I have a scootmobile that is moving with 100 joules of kinetic energy. And it has a mass of 1 kilogram. It's a very light scootmobile. Don't question it. We're in the future. And my V is unknown. You can be asked to calculate V. And so either you now understand how to rewrite formulas. If you don't, you can ask me to explain that in more detail at some point. And otherwise, remember the formula that I'm about to show you. So in a question where you get kinetic energy and mass, and you need to calculate V, you have to rewrite this formula so that you get V equals something. How do we do that? What I do, I'll just walk you through it. First, to get rid of the half, I have to times both sides by 2. And that gets rid of the half. So now I have 2 kinetic energy is equal to m times v squared. I got rid of this half by timesing it by 2, because 1.5 times 2 is equal to 1, so that falls away in my formula. That's step 1. Step 2, I divide both sides by m, so that I get m out of the way. Then I have v alone, correct? So now my formula looks a bit like this. Divided by m is equal to v squared. Okay, perfect. How do I get rid of a squared? Is that I root both sides. So my final formula looks like this. The root of 2 times e divided by m is equal to v. Either, I hope you understand how to rewrite formulas, because eventually that will be something that you have to be comfortable doing. For now, know this formula out of your head if that's a struggle point, and do focus on that on the coming time so that you are able to do it. Yeah, but for now, this is your formula. And so if this is my question, I can easily again plug in the digits into this now new rewritten formula. So the root of 2 times kinetic energy is 100 divided by the mass, which is 1, is equal to v. So 100 divided by 1 is still 100, times 2 is 200. The square root of 200 is far beyond the scope of my mind. Maybe like 14-ish, question mark, movement meters per second. Okay, so that is how you could calculate V. That is just something that can be asked. So either memorize this formula or practice with rewriting different formulas. There's plenty of websites to be able to do that. Okay, that is kinetic energy. Main thing, mass and speed give something its kinetic energy. The higher the mass, the higher the kinetic energy. The higher the speed, the higher the kinetic energy. This is the formula, some calculations with it, and this is the rewritten formula that might be asked in some questions. Then we have something that we need to cover, which is friction. And friction is the opposite force of movement. So let's imagine you are entering a competition in which you have to push this big 10 kilogram block of iron the farthest. That is your competition. You have this on the floor and you need to push it, and it needs to go the farthest. You can only push it one time, and then it has to roll on itself, and it has to go as far as you can. And in this competition, they give you 2 options. So they either allow you to push this block of ice on. Let me just draw the scenario out. Either you push this block of 10 kilogram iron on an ice path, or you push this 10 kilogram block of iron on asphalt, so just on the road basically. And if your goal is to push this once and get it the farthest, to slide the farthest, which one are you choosing? Probably the ice, because it slides way further. And what does that tell us about the friction? The friction of the ice is lower. So the friction of ice is low, whilst the friction of the asphalt is quite high. If I push this block of iron on the asphalt, it's probably gonna move a little bit and then stop right here. Whilst on the ice, it's gonna just slide on through and maybe stop way further down the line. Yeah, so that is what friction is, how we can easily see friction, right? Is how far does something travel once it's moving? And the higher the friction of a surface, the less far that it can travel. Okay, so friction is, let me just bang, is the counterforce of movement. That is what it is. And it acts on an object once two surfaces are in contact. So in our example, our two surfaces is the ice and the block of iron, two first surfaces, and they are on top of each other, so they are in contact. Check. And B is that there is motion. Okay? And that is when there is kinetic friction. So let's say we have this box and I'm pushing it this way. I know this is the counter force of movement. So if this is my force pushing it forward this way, then I know 180 degrees the other way is going to be my force of friction, the exact opposite way. If something's moving this way, the friction will be moving this way. While moving, will be acting that way. If I'm moving something that way, friction is this way. It's always the exact opposite because it is the counter force of movement. Okay, then what factors affect the amount of friction? What factors affect friction? There's several that you need to know. First of all, just like here, is the type of surface, right? So the roughness of the surface. Roughness of surface. Bang, perfectly written, beautiful. The roughness of the surface. Second, we have the amount of, sorry, give me 1 second. The amount of area touching. So how large is the contact area? So surface area. So for example, if I have just this on a path and I move it forward, it has way less friction than if I have a huge box on a path because there's more points of friction with the floor. Same if you're on the bike, for example, and you're moving through the air has friction on you, resistance. If you open your jacket, there will be more resistance, and so a larger surface area, so more resistance. C, the last one, is the amount of speed or the amount of kinetic energy. The faster you are moving, the more friction you are experiencing. If you are just moving a little bit, you will also just experience a little bit of kinetic friction. Yep. So the faster you're moving, the more you are interacting with your surface and the larger the amount of friction you have. Yep. So friction is the counter force of movement. If you're moving in one direction, friction is the exact opposite way. It has to be in contact with something to have friction with. So in outer space, you have no friction because there is nothing to be in contact with. And there has to be then movement. And then how can we increase or decrease friction? So either we can increase friction if we make our surface rougher. It's more difficult to move our block of iron on asphalt or even sand in comparison to ice, because ice is way less rough than those two. It's easier to move our block of iron if it was way thinner and there was only one tiny contact point with the ice, it'd be way easier to then move that block of iron. So for example, maybe we can put our iron block on this little pedestal. And now we have less friction because there's only these two small contact points with the ice, so there's less friction and we can more easily push it through. Last one is the amount of kinetic energy. The faster that this is going to be moving, the more friction that it is experiencing. If it's just moving a little bit, it will only experience a little bit of friction. Cool. Then what is the formula for friction? The force of friction is equal to the coefficient of friction times the normal force. If we remember the normal force, that is perpendicular to the gravitational force or the surface on which it lies. Yeah, so normal force, go back to unit 4 for that one. This coefficient is just a number. So for example, it can be 0.1 for ice, for example. I don't know if that's the actual one, but the lower it is, the less friction you have. For example, asphalt might be 1.2 coefficient, so it is more friction. And if we put it in sand, that maybe has 1.7 friction. So the higher this coefficient, the more friction that your surface has. So for example, if you see a question, hey, would the coefficient of friction be larger of ice or of asphalt? You say it's of asphalt because it has a rougher surface, so a higher coefficient of friction. Okay, that is basically it. Oh no, I have one last thing that you need to know, is that we have two forms of friction. Friction S and friction K, and they stand for two different things. This is static friction. What is static friction? What does static mean? Static means that you are not moving. So for example, just standing still means that you are static. So static friction is the friction on an object that is not moving. So for example, on a ramp, if I place a box, it's not moving, but it still experiences friction because otherwise it would just slide down, right? If there's no friction. If I turn this magically into ice, it will probably start slipping down because that friction is lower. Okay, so that is static friction. The friction an object experiences when there is no movement, static. And then we have kinetic friction. What does kinetic mean? Again, that means movement. So somebody that's running has kinetic friction because it is moving. So kinetic friction is friction once you started moving. Okay, so that's the two different types of friction that you should be acquainted with, let's say. That static friction, I know what static means. That means not moving. So that is the friction on objects that are not moving. Kinetic, I know what kinetic means. That means movement. So that's the friction on objects that are experiencing movement. Yeah? Two things. Cool. And I hope this helps, that the static friction is for a box that's sitting on a slope. So maybe you can also just do that, well, don't do it with your laptop, but maybe like hold your hand at an angle and then place like a box of chocolates on it. And that it's not going to slide down because it is experiencing static friction. Okay? Cool! That's it. Enjoy it. Bye.